Let's discuss Gyro Numerical, which is part of NAVED Achievement Phase 2 question, and it's compulsory 25 marks question, and it's very simple. Sometimes it's only the numerical come 25 marks, so that you will score 25 marks easily. Sometimes it will separately, like 15 marks it will come for the numericals and 10 marks come for the theory. So today I am going to discuss only the numerical parts. Theory parts I will discuss in my next video. For Gyro Numerical there is two video. One is for the numericals and the two important question which is coming several times in the past examination, and the second part of my video is the past paper solution. So if you do watch these two videos, you are able to get 25 marks. Okay, so this is a compulsory question. So we start with the formula. The first formula is, if the question is say gyro is damp in tilt, that means both error present. Which two both error? One is course latitude speed error, CLS error. One is damping error. Okay, so CLS error, that means course latitude and speed error. Formula is 10 course latitude speed is equal to minus V cos co 900 cos latitude plus V sin course. Okay, and for damping error formula is DE, that means damping error is equal to K 10 latitude, where is K is constant. Value is always take 1 by 40 if it is not given in the question. If it is given in the question, then we have to take that value, otherwise we have to take 1 by 40. Okay, so naming. So course latitude speed error, the naming is depend upon the where the course of the vessel. Okay, so if it is in northerly course, that means from 270 to 090 or northerly course, the naming is west, and from 090 to 270 it will east. Whereas damping error, it will opposite, it will as hemisphere. Like if your vessel in above the equator in the north hemisphere, then it will east, otherwise it will, if it is in south hemisphere, it will be coming west. Okay, so the naming is very important. If you remember one naming, that other one is opposite. So this is a basic funda. This main two formula is used in the numericals, this main. Okay, now if the question is given damp in azimuth, if it is given question damp in azimuth, that means only course latitude and speed error is present, no damping error is present. Okay, so damp in azimuth means only course latitude speed error present. So when gyro is uncorrected, then gyro course and bearing is equal to 2 course bearing. Then find out course latitude speed error. Damping error will be opposite to course latitude speed error. Okay, so when the gyro is uncorrected, if the question is given when the gyro is uncorrected, that gyro course and bearing is equal to 2 course on bearing, then we have to first find out the course latitude speed error. Then whatever we have the value with the opposite, we get the damping error. So for example, if we calculate course latitude speed error is equal to 5 degree east, so no need to calculate damping error by the formula, we directly use damping error is equal to 5 degree west. Okay, now correctors are left at 0 speed and 0 latitude, means the gyro damp in tilt is left uncorrected. Okay, if the question is say corrector are left at 0 speed or 0 latitude, that means we have the gyro damp in tilt, and then we use the damp in tilt formula. Now again the same formula we are repeating so that you will understand. Damping error, which is showing DE. If the question say damp in tilt, that means damping error. If it's damping error, that means already damping error. If settling error, that means also damping error. Okay, this all three is meaning the same. So formula is sin damping error is equal to K 10 latitude. I already tell you the K is a constant, value is 1 by 40, and latitude we have to take the latitude, but if it is two position given, so that we have to calculate the mean latitude. So latitude, if two latitude is given, initial latitude and final latitude, then mean latitude in the formula we have to use. Okay, naming is same. If in north hemisphere we have to put east, if it in south hemisphere we have to put west. Okay, and you have, if the theory part is coming, no, then damping error, you have to make this diagram, so it will give you good presentation in your exams and you will get more marks. Okay, by this diagram you will get this east and west. North, in north hemisphere it is east and in south hemisphere it is west. Okay, so if it is see north hemisphere, it is error east, because, and in south hemisphere damping is west. In equator damping error is nil. When we know that the damping error of one latitude, we can find the damping of different latitude by simple ratio formula. Okay, so that formula we are going to use, sin damping error 1 is equal to 10 latitude upon 10 latitude. Okay, so this is a formula. If we know the one latitude and one damping error, so we can cross multiplication and we get the other damping error. So let's do the example. Damping error 1 is 2 degree east at latitude 20 degree north. So find damping error at latitude 40 degree south. So sin 2 degree divided by sin damping error 2 is equal to 10 20 degree divided by 10 40. Okay, so cross multiplication. So sin damping error 2 is equal to sin 2 into 10 40 divided by 10 20. We get the sin inverse, and then we get the damping error 2. So this is all about the damping error. Now the course latitude and speed error, also known as steaming error. Okay, 10 course latitude speed error is equal to minus v cos co. V is speed of the vessel. 900 cos latitude plus v sin course. Where latitude, if latitude initial and latitude final latitude is given, then mean and latitude we have to select same as damping error. So westerly error in northerly course 270 to 90, and easterly course on all southerly course 090 to 270 already we discussed. So course latitude space is based on the course and the damping error is based on the hemisphere. The next formula is approximate formula. This type of numerical very less time coming, not very frequent, but it's very simple and we have to go. Approximate formula. When we know that a course latitude is speed 1 of one latitude, we can find the course latitude is speed error of different latitude. When the course and speed are same, by the simple ratio formula. Same like damping error, we get the, if we know that one damping error of one latitude, we can find the second damping in the different latitude. The same, the course latitude speed also error we get the, if we know that one course latitude. Okay, the formula is 10 course latitude speed error 1 divided by 10 course latitude speed 2 divided by cos latitude 1 divided by cos latitude 2. So just remember all this formula. When we solve the numericals, you will be able to understand the concept and you are able to solve it. It's very easy and you easily score 25 marks. The performance test formula. When the gyro compass finally settles down, the actual settling point can be known. If the theoretical settling point as calculated above and the actual settling point are practically the same. If the difference is less than 0.5, then performance can be deemed satisfactory. So this numerical also come, but it's very less. So this type of numerical I think 2 or 3 times only came. So generally in this time first we have to make diagram. Okay, 3 time we in the question we have the 3 time and 3 course, and then mark meridian, put all the heading mark as A, B, C. Okay, if A and C reading, this is important, if A and C reading are the right more than 00 degree of the meridian, then gyro compass is north hemisphere. If A and C reading are on the left less than 360 degree of the meridian, the gyro compass is in south hemisphere. You can see. Okay, this is B, this S, this C and A. This is your meridian. blue one is meridian, this S is your settling point. So that means if your diagram become like this, if A and C reading are the right, if you see A and C reading is right of the meridian, this is your meridian, this blue one is meridian, and this C and A is your right side, that means the vessel in north hemisphere. But if it is C and A, if you see the second diagram, A and C is the other side, left side of the meridian, that means it is in south hemisphere. I will share my PDF also, so you that you will also understand, and you keep the copy, so that when you watch video and you will solving, you have also the copy, so that you will easy. Okay, so damping factor formula. So damping factor formula is B, difference between B and C, dash difference between A and B. Okay, then percentage of damping, which is also known as F factor. So 1 minus F, which is we calculate here, 1 minus F into 100, it is coming in percentage. The period of the compass, when the time of A, B and C are given, then period of the compass is the time difference between A and C. When the time of settling point S is also given, then period of the compass is the time difference between A and S. Theoretical settling point is equal to B plus minus C difference between B into B difference between A, and divide by C difference between B plus B difference by A. So sometimes this formula we are going to use this one also. Okay, so let's move to the numerical. Also there is two numericals came, which we are going to use cosine formula, which we already used in the great circle, in the phase 1 great circle sailing. So you go through that. Cosine formula, angle formula, when the a side and two adjacent angle subtending the side are known, we can find the third angle. Okay, so if a side like A and B we know, okay, and we can find the P. So we already use this formula in the great circle, so we are going to solve this type of numerical also. So please go through this formula. If you have any difficulties in this formula, you watch my great circle sailing videos, you will able to understand. Okay, now I'm going to solve the numericals, which is coming past memory paper in Feb 19, November 22, Feb 17, Feb 13, Jan 12. This numericals is coming several times. So in this video I am going to solve two numericals which is coming very frequent. Okay, so our first numerical is a ship sail at 1400 hours from position 43 degree north, 058 degree 30 minute west to pick up a pilot at 1900 hours in position 44 degree north, 060 degree west. The current had been setting 180 true at 1.5 knots throughout. The ship is fitted with Sperry gyro, which is uncorrected for damping and north-south speed error. If the damping ratio is 1/40, calculate the gyro course and the ship speed which needs to be maintained to reach the pilot station in time. So first of all we have to make the diagram. So let's consider this is our position A, and we have the second position is like this. We have the current, so we okay, so this is our current, this is course made good, this is CTS, This position A, 1400 position, 43 degree north, 058 degree 30 minute west, and this is our pilot point, 1900 hours position, 44 degree north, 060 degree west. Okay, so we have the course made good and we have the current, so it's like counteracting the current, so we apply the current on initial and we get the CTS. So it is 1.5 rate. So for this is 1400 and 1900, so 5 hours, so into 5. Okay, this diagram we have to make. Now we have to proceed to the solution. So this is position A, this is position B, and this is position C. So first of all we have to calculate the position C. So for calculating position C, D lat is equal to, so it is 5 hours, so 1.5 into 5, so we get 7.5, and it is going in the south direction, so naming is south. Okay, the first position is latitude 43 degree north, and D lat we get 7.5 south. Okay, so we get the position C. Position at C is 42 degree 52.5 north. Okay, and we have the longitude is the same, 058 degree 30 minute west. So D long is 0 because it is on the same longitude. Okay, so we get the longitude at C is same, 058 30 minute west. Now this we get the position at C. Now we have to find course made good and speed made good. That means we have to going to find out this course made good and speed made good. Okay, so we have the to find course made good and speed made good, and A to B. Okay, now at 1400 latitude is 43 degree 00 north, at 1900 it is 4400 north, longitude 058 degree 30.0 west, longitude at 1900 is 060 degree 00.0 west. So we calculate the D lat and D long, 01 degree 00 north, and D long is 001 degree 30.0 west. Okay, so D lat we have to multiply by 60 and we get the 60 minutes. We have to calculate M latitude, so both latitude 43 degree 00 north plus 44 degree 00 north because the same name, and divide by 2, so we get the 43.5. Okay, this D long we multiply by and we get the 90 minutes. We know the formula of departure is equal to D long cos M latitude. Okay, so put the value 90 degree cos 90 minutes 43.5, so we get the departure is 65.28. Okay, then we have to find the course. So 10 course, we know the formula, departure upon D lat. We already studied in the second met and the phase 1, the Rumbrine course. So put the value 65.28 divided by 60, so we get the 10 inverse and we get the value of 47 degree 24.9 west. This is our course, north west. So D lat is equal to distance into cos co. Okay, so we need to find out the distance. Okay, so 60 divided by cos 47 24.9 is equal to distance. Okay, so this one go that side. Okay, so distance we get 88.66 miles. So of course we have the time and we have the distance, so we get the speed 88.66 divided by time 5 hours, so we get 17.73 knots. Okay, this thing is clear. Now we have to find the CTS and engine speed. Now we have to find this one. We have the position C, we have the position B, so we have to find the CTS. Now to find CTS engine speed, we have to go C to B. Okay, the position C we already calculated on the top. C is equal to 42 degree 52.5 north, and at 1900 position we already known 44 degree 00 north. Okay, longitude 058 30 minute west, longitude at 1900 is 06000 west. Okay, so we calculate the D lat, which is 67.5 north, and D long is same as 19 minute west. So we need to calculate M latitude 4326.2. Okay, so we have to calculate departure is equal to D long cos M latitude. Okay, 19 cos 4326.2, so we get the value 65.35 minutes. Put the value in the 10 course formula so that we can find out the CTS. So departure upon D lat, put the value 65.35 divided by 67.5, we get 0.9681. So 10 inverse, so we get the course north 44 04.4 west. Therefore D lat is equal to distance cos co. Therefore D lat divided by cos co is equal to distance. Now distance is equal to 67.5 divided by cos, put the value 4407.4, and we get the distance is equal to 94.03 minutes. So engine speed, we have the distance, we have the time, so 94.03 divided by 5, so we get 18.8 knots engine speed. Now we have the course made good, speed made good, CTS and engine speed. This all we 4 calculated already. Now put the value in the sign. Damping error is equal to K 10 latitude. So K value is given 1 by 40. Already we discussed when I am explaining the formula. When the two latitudes given, we have to select we have to put the mean latitude. So 10 mean latitude of course made good, so 43.5. so we get the damping error is 1.36. naming, it is in north, so east and west, so we have to put the east. Okay, naming is depend upon the hemisphere, so it is north hemisphere, so east. Now 10 course latitude speed error is equal to minus V cos divided by 900 cos latitude plus V sin course. Now we have to put the speed, so we have to put the engine speed, so minus 17.74. because of this two formula we have to calculate this course, engine course made good, speed made good, engine speed and the course to stay. Cos 312 35.1 divide by 900 cos 43.5 plus 17.74 sin 31235.1. So we get minus 1.07 west. Okay, so 10 inverse. So cos speed here is 1.07 west. Why it is west? One is sine is it is negative, so it is west. Other is if it is in northerly course like this from 270 to 90, it will come west. Okay, so course speed here is 1.07 west, and we have the damping error 1.36 east, so we get the total error is 0.29 east. Okay, so true CTS we calculate 31555.6. so gyro CTS is equal to 31555.3. so this is our answer, and this is total our answer. So it's frequent question and it's coming several times, so it's very simple. Let's move to the next question. This question also repeated many times. So question is at 00 hours 00 minutes 00 second GMT in latitude 45 degrees south and longitude 000 degrees, spin axis of the free gyroscope is pointing 120 true. At what time it will point 270 true on the same day? So we have to make the diagram. Okay, so PZX triangle, longitude 000 south, so it is south, so equator will go this side. North, east, south, west. So since it is south latitude 45 degrees, so the pole will go there. So pole is zenith, is equator. So first is 120, it's pointing 120, so this is 90, so 120 somewhere here. Okay, so 120, and the second time is 270. This is P1 and this is P2. Okay, now we have to solve this new. So this is considered X and this is X dash. So what is given in the question? Z 60 degree. Okay, because we have this is 120, so this one is 60 because 180 minus 120 60. Latitude we have 45 south, so PZ is equal to minus 90 minus 45 is equal to 45, and PX is equal to PX dash. Okay, now we use the Napier formula. We have to going to solve this first triangle. Okay, then we have to going to move to the next question. So in P, this P, Z, X, this X, ZX, this one is 90 degree, so ZX is equal to 90 degree. So by Napier's rule, ZX is equal to 90, so ZX 90 minus PX, P minus 90, 90 minus PZ. Okay, So sine 90 minus pz is equal to 10z into 10p minus 90. Okay, sine 90 minus pz we already know, sine 45, 10z is equal to 10p minus 90. Therefore sine 45 divided by 1060, z value we have 1060, so 10p minus 90. Therefore 10 inverse, so p minus 90 is equal to 22.20. So p1 is equal to 90 will go that side, so 90 plus 22.20 is equal to 112.20. so this first p1 we get. Now in the second triangle, in pzx, zx is equal to 90 by Napier's rule. So sine 90 minus px is equal to cos z into cos 90 minus pz. Therefore sine 90 minus px is equal to cos 60 into cos 45. So 0.3535. So 90 minus px is equal to 20.70. So px is equal to 69.29. Now in second triangle, triangle PZX dash, again we use Napier's rule. In the z is equal to 90 degree. Now this is 90 degree. Okay, this is 90 degree. Now we are discuss about this triangle. PZ, px dash 90 minus x, 90 minus px, 90 minus p. Z is equal to 90 degree. So by Napier's rule, pz is equal to 45. We already calculated. Px is equal to px dash, which is 69.29. Therefore sine 90 minus p is equal to 10 pz into 10 90 minus px. Correct? So 10 45 is equal to 10 90 minus 69.29. 10 45 into 10 20.71. So sine 90 minus p is equal to 0.378. So sine inverse, so 90 minus p is equal to 22.21. So p is equal to 67.79. So p is equal to p1 plus p2 is equal to 112.20 plus 67.79 is equal to 179.99. Now we have to find the time interval which is asked in the questions. So 120 to 270 time interval. So we get the total p value 179.99, rate of travel 15, so 11.999. So if you convert in the time, so time it will be point at 270 is equal to 11 hours 59 minutes and 57 seconds. So these two numericals is very important and is repeated many times. So hope you understand the basic of the gyro compass formula. This video is only about the formula and this type of these two numericals. My next video is solving from latest from 23 to 2014 till 2014 all the numericals. If you want this PDF or you want to my second video PDF, comment me, and thanks for watching. Best of luck for your exam. Thank you.